Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is part 7 of Thermodynamics, class 11 chemistry. Friends, in this video we will learn about the free expansion of gas. What is the work done in that case and what is internal energy? What is the relation between internal energy, work and heat in free expansion. The second thing what we are going to study is isothermal irreversible process and isothermal irreversible process. So let's start. First thing is free expansion of gas. This should also be termed as the expansion of gas in vacuum. Gas in vacuum. So in this case, we will study about the ideal gas only. Most of the time we are studying about ideal gas. So when a gas is expanded in a vacuum, or it is called free expansion, what will happen in that case? The external pressure in that case is 0. Then only it's a vacuum. Now we knew that the work done is always equal to minus P external into delta V. So if P external is 0, in that case the work done is also be 0. Okay, so we can say when there is a free expansion of gas or there is a expansion of gas in vacuum, the work done is 0. Now what about internal energy? Since internal energy is equal to Q plus W. So in free expansion W is 0, then internal energy only depends on the heat transfer. And one more situation will be there at constant volume. So we can say now that if the process is carried at constant volume, the change in internal energy is equal to the heat transfer. Clear up? In the case of free expansion and at constant volume, the change in internal energy is equal to the heat transfer. So friends, this much is clear. Now come up to the next topic, which is change in first law of thermodynamics for isothermal process. First thing you understand what is when there is a isothermal process, what will happen? In isothermal process, it means isothermal means the temperature is constant. When the temperature is constant, there is no transfer of heat, no transfer of temperature, no change in temperature. It means the change in internal energy is also 0. So this is called isothermal process. Change in internal energy will be 0. So when the internal energy is 0, then what about the first law of thermodynamics? First law of thermodynamics is delta U is equal to Q plus W. When delta U is 0, in that case, the heat transfer is equal to minus W. There is a change in the first law of thermodynamics for isothermal process. Now, if the isothermal process is reversible, we knew that W is equal to minus P external into delta V for reversible process. So in that case, what about Q? So for isothermal process, Q is equal to minus W. So here Q is equal to minus W is equal to P external into delta V. The minus will cancel out with the minus. So we can say finally the heat is equal to P external into delta V, and this equation we can use when they ask to find out the heat transfer in a isothermal reversible process. Okay friends, now in the same way for isothermal irreversible process, we knew that work done is equal to minus nRT natural log V2 upon V1. And one more thing, for log W is equal to minus 2.303 nRT log V2 upon V1. We studied earlier that work done is equal to like this in irreversible process. So from here we can find the value of Q also. So Q is equal to minus W. It means Q will be, so minus will be cancelled out with the minus, and nRT natural log V2 upon V1 will be the equation which is coming out for isothermal irreversible process. Here in the same way, Q is equal to minus W. So minus and minus cancel out. It become 2.303 nRT log V2 upon V1. So both the equations are valid. We can use as per the conditions. So friends, that's all for today in this video. These equations are important for the numerical point of view. So don't skip the video because this will save your life while doing the numericals. So do like, share and subscribe the channel, and don't forget to press the bell icon. Till then, thank you.